Hi, welcome everybody. I'm Lucian Fogoros. I'm the co-founder of IIoT World, and on behalf of my team, our speakers, our sponsors, supporting organizations, thank you for joining. We have a pretty diverse perspective today from managing consultants, analysts, end users, government representatives. So I look forward to this session. We start off with broadening, how do you extract more value leveraging either tools or processes, like for instance, AI or digital twins or data historians, to how to do it in a secure way. So stay tuned. All the speakers are live, and I encourage you to post questions in the Q&A. With that, I'd like to introduce the moderator and our newest Board of Advisors, Hamish McKenzie, who will moderate this session.
Fantastic. Thank you very much, Lucian. So good morning, good afternoon, or even good evening to some of you, depending on where you are in the world. My name is Hamish McKenzie, and this is the first session of today's Energy Day. This session is AI-enabled predictive analytics for grid resilience, brought to you today by IIoT World. Before we get started, I just got a little bit of housekeeping to do. So the session is going to last just shy of an hour. I'll introduce the topic, introduce the panelists, and we're going to be getting a lot of valuable insight from them, obviously. But we will make sure we leave time at the end for some questions for the most important people in the room, and that is, of course, you, our audience. As Lucian just mentioned, please do put your questions in the Q&A function in the platform, not in the chat. It just makes it easier for me to find them, and you're more likely to get your question answered if you use the Q&A tool. So please do that. A very quick preview for some more up-and-coming IIoT World events that are coming soon. We've got quite a few. I'll just mention three. We've got Manufacturing Day coming up on May 22nd, Smart Buildings Day coming up on July 24th, and Sustainability and AI Day coming up on September 10th. So check out the IIoT World website for all the details, get your registrations in. And with that said, let's get stuck into today's session. So we're going to be exploring the integration of AI-enabled predictive analytics to enhance energy grid resilience. And we're going to be delving into how AI algorithms can forecast grid stress points, for example, optimize energy flow, crucial for grid's ability to withstand and recover from disruptions, of course, and those disruptions caused by maybe fluctuations in renewable energy supply or fluctuating demand as well. And I'm delighted to say we've got several experts with us to help us move through this topic and get some really great insight. For those of you who've been to a few of these, the first guest will probably be no stranger to you. That is Ravi Subramanian, who is Director of Industry Solutions Manufacturing at HiveMQ. He's a product management leader with extensive experience, and he's generated revenues and cost savings of over 10 billion for companies like Motorola, GE, Bosch, Weir. He's also worked across many different industries, too many to mention really, but mining, oil and gas, industrial automation, automotive, mobile devices, the list goes on. At HiveMQ, Ravi is in charge of evangelizing and enabling sales of the HiveMQ solution amongst manufacturing, energy, logistics, and industrial automation customers. And he's a very experienced presenter all over the world, online, offline, places like Hannover Messe, SPS, ICC, IIoT World, Smart Manufacturing. Again, the list goes on. Very experienced guy, and it's great to have you with us, Ravi, today.
Thank you. Welcome.
Welcome. Next, we have Ryan Kahan, Managing Partner at Axiom Manufacturing Systems. He's a transformative leader with a passion for driving growth through collaboration, innovation, and empowering the front line. He has a proven success in a broad range of environments, from Fortune 500 companies right down to startups. He's very growth focused with a consistent record of sustained above market performance. He's a digital transformation and industry 4.0 expert and a very passionate customer evangelist, dedicated to successful long-term partnering with customers. And he's also a very devoted mentor and team champion, helping develop leaders within his own organization. So welcome, Ryan. Great to have you with us.
Good to be here.
And next we have Becca Gillespie, who is Managing Director at the Energy Systems Network. Becca joined ESN as a Managing Director in January 23. And before that, she worked as the New Products and Services Lead at Duquesne Light Company, which is the electric utility in Pittsburgh. Before that, she was a Sales Director and Product Manager at Unit Energy, which is Unit Energy's Technologies, a flow battery startup company. And she's also worked at the Federal Energy Regulatory Commission as an energy analyst and as a propulsion engineer at NASA. And I'm almost certain there's a joke in there somewhere about this all not being rocket science in comparison with that. But I'm sure Becca's heard all those jokes already, so I'm not going to go there. She has a BSc in Mechanical and Aerospace Engineering from Princeton and a Master's of Science in Public Policy and Management from Carnegie Mellon. She also holds a patent for a nitinol valve, and I'm not going to pretend I know what that is, but it has something to do with in-space propulsion systems. So I'm beginning to think that she's really actually a rocket scientist. Anyway, we're delighted to have you with us, Becca.
Great. Thank you so much, Hamish.
You're very welcome. And finally, a few words about me, your moderator. As I said, my name is Hamish Mackenzie. I'm a former IDC analyst, and I've been running my consulting, advisory, and coaching practice from here in Munich, Germany since 2006. I walk alongside CEOs, founders, and other senior executives in technology companies in US and Europe, really helping them focus on how to improve their growth efficiency in all sorts of different ways. And I also help them become more effective leaders by getting them to freeing up their time really to focus on strategy and evangelization rather than the day-to-day nitty-gritty of operations, which is best delegated to other people. Anyway, if you'd like to know more about me, please look me up on LinkedIn. I think I'm the only Hamish Mackenzie in Munich, so you shouldn't have too much problem finding me. Quick reminder, please get your questions into the Q&A function, not the chat. And with that said, let's get into it. So before we start talking about the ways we can use data to, for example, improve grid reliability and resilience, we need to first have a look at some of the equipment which enables us to get that data in the first place. And that means delving into the world of sensors, of course. And I want to talk to Becca about this first. And before we get on to sensors specifically, I know you've got some thoughts on distinction between resilience and reliability as far as the grid is concerned, Becca. And obviously they're both important, but they're not the same thing. So could you just give us a quick perspective on the difference between the two and why it's important to make that distinction?
Great. Yeah. Thank you, Hamish. Well, having worked at FERC, they're very precise there about the meaning of resilience versus reliability. And I know it does change from organization to organization, and it does change from different parts of the DOE. But in the FERC definition, in FERC and NERC world, at least, it generally means reliability is keeping the grid alive as often as possible, keeping the lights on as often as possible, and withstanding the sort of day-to-day interruptions that might be caused by renewables or a load going high and low or things that just can happen every day. Yeah. So when I think about how AI is starting to be used on the grid to use the data that we already have or collect new data, it's generally in the world of reliability, because that's where you're trying to, an AI algorithm is capable of learning because they only have to look at a couple of years of data and they can start learning what's going on and then see those outages or see those events and sort of understand that. And then the other resilience is keeping the grid alive in sort of extreme examples, or sort of hardening the grid, building out more copper, literally more copper on the wires, and more duplicative of everything, transformers and whatnot, as well as possibly predicting those once in a lifetime events that you just don't see coming at all. Huge weather events, major world events, political, geopolitical, whatnot. And I'm sure AI is being used on those too. Hopefully somebody else, not the people that work at the utility. But I guess there's starting to be some AI in the resilience space as well. But for the most part, where I've seen it start to take hold is in reliability, because there's more data to learn from at this point. But yeah, so those are the basic distinctions. Reliability is, there's a storm, there's an outage, you don't have your lights on, that impacts your reliability metrics. Resilience is the event in Texas where there was, coal piles were freezing and the wells froze up, and there was a huge major outage for a long period of time. So yeah. Yeah,
I remember seeing the pictures of incredible stuff there. Yeah, okay. All right, so that I think that gives us a good context. So let's look at sensors in particular then. What kind of sensors are currently being used mostly to monitor the electric grid right now? And what are some of the innovations, some of the new types of sensors that are coming on stream down the line?
Yeah, I mean, so one of the big inhibitions, and I can talk about this a little later, but one of the big inhibitions to using AI at times is that we don't have all the data that people sometimes presume we have on the grid. So there's two parts of the grid for those of you that are new to the electric grid. The transmission grid is high voltage, carrying electricity long distances, and that's what you see when you're driving by on the highway and you see those big towers. And those do have really good monitoring going on. So they actually sense their voltage, they do sense their current, they always know what's flowing where. For the most part, those are well monitored lines. But what we don't always know, and where sensing is kind of starting to play a new role, is in the capacity of the lines. So how much electricity a wire can carry depends on the temperature of that day. It depends on the wind speed, which sort of cools the wire as it goes. And so in my previous utility, they were doing a pilot project using a LiDAR sensing device that could start to see the sag in the line. So the sag sort of is the way you can infer how hot that wire is, for example, and start getting a sense of the capacity. But for the most part, a transmission grid is really well sensed. It's just, it's really hard to get your hands on that data. There's a lot of cybersecurity and concerns around people touching or seeing or interacting with that data. So while we have all the data there, it's not necessarily easy for us to start, playing with it in a sort of open environment. Then there's the distribution grid, and that's what most people know the distribution grid because you pay a bill every month to your distribution grid provider, and you know their name, and you know how much they're charging you, and that is kind of in an in-between land of what we know and what the data is coming in from that.
Okay.
In my previous utility, there were still those circle charts measuring the voltage and the current at a lot of the substations, literally pieces of paper with a pen that kind of went up and down. So it's really not fully sensorized as much as people think at this phase. But I guess one major innovation in the last 10 years that's changed things is the deployment of advanced metering infrastructure, so AMI meters. And that, you guys, for people, again, that are new to the utility space, you would know that because there's a guy came and knocked on your door, a woman came and knocked on your door, and then they put a yellow box or whatever color, a new shiny meter thing outside of your house. That would be your experience of an advanced metering infrastructure. You'll also probably see a little line item on your bill, it says AMI charge. It's like an additional 6 cents a month. And that's another experience people have with the AMI meter. But what it really means is every house, you actually have the real time, you can have real-time current, voltage, and you can actually measure the health of the grid throughout the system. So it's actually a huge innovation for how grids are monitored and measured throughout the world. And then there are other things that are being considered in the world of monitoring on the grid. So some people have deployed interrupters, which are basically fault devices or something similar to that, which they actually sense when the fault has happened. And they have there's a new device that can measure the health of a pole top transformer, like what's the temperature, and getting IIoT data off that pole top transformer. I had an executive describe to me pole top transformers are like the ballpoint pen of the utility, so they didn't want to monitor and do predictive maintenance. So there's a debate there as to whether we should be, you don't have a predictive maintenance on your ballpoint pen. So maybe for them that's a ballpoint pen. So maybe it doesn't matter all that much. Okay. But starting to monitor those, and then there's also much bigger transformers at substations, for example, and starting to get the temperature data, the ongoing real time, sort of predictive maintenance type data coming off of those is a new area of expertise. Or of data collection that's happening. So there's not always as much data as people think there will be, but kind of utilities, I would say, are in the world right now of making that digital twin, pulling the data together, getting it all in one place, making it visible, making it as friendly as possible. And and sometimes they're not thinking about deploying new sensors because they haven't really made use of the AMI data. That's the like elephant in the room, is this like massive quantity of data they've all gotten in the last, or starting to get, or have gotten in the last 5 to 10 years, and just pulling it all in and starting to really make use of it hasn't necessarily happened everywhere yet, but there's a lot of opportunity for AI in that space. And then, there's other data out there in the world. Some people talk about crowdsourcing when the pole's leaning, or crowdsourcing or using satellite data to figure out which trees are going to hit which poles in the coming future. So there are use cases where people take data from off the grid that you don't need to sense and kind of try to bring it for use cases within the utility. Yeah.
Okay. Yeah, I mean that issue of having lots of data and not necessarily making the most of it. Yeah, I mean this is common to almost any industry I can think of, to be honest. And I think everybody is hoping that AI is going to be the kind of killer app which enables us to, or enables businesses in particular and utilities and everybody else to actually start making full use of this, these enormous quantities of data that we already have. All right, but assuming generally speaking that there is a desire to get more sensors out there and especially within the from the Internet of Things perspective, what are some of the challenges in order to do that, to get those sensors out there?
Yeah, I mean, I guess the biggest hurdle for utilities is the security issue. So there's NERC regulations which determine what you can put in a substation, where it has to be made, and how cybersecure each of those things do. So anything within the substation is much more important. Again, maybe a pole top transformer is a ballpoint pen, but your substation transformers are huge and highly expensive assets that can take out entire neighborhoods. And so getting something inside the substation that's actually sensing that is both wonderful, but also it's highly restricted by NERC. Because it's a critical asset for the nation, essentially. Partly because our grid is not as resilient as we'd like it to be, right? So we could take out one substation, it can have a ripple effect, and so the resiliency, as it grows, we'll have to worry less about that. But for now, we have to be very, very careful with each of our substations. So the cybersecurity is ultimately one of the major issues to getting more sensing out there. And ultimately, that's also one of the difficulties in using these new technologies, not sensing, but actually using AI, for example, to start reading all this AMI data and predicting outages and predicting based on historical data and based on, again, the outside data like the satellites and the crowdsourcing. Or the phone calls even, do still call your utility when your power's out, please, people, because they still need that data, honestly, as much as sometimes people think that should be in the past by now. But using that to the maximum capacity can be really difficult for utilities because they have to really restrict who can come in and start looking at their data and how it's managed and how it's done. And getting it all in one place even can be difficult because of those restrictions. So yeah, I think that is one hurdle, and then the other is kind of what I said before. Why bring on new sensors when you haven't really fully made use of your old sensors? So they're just so focused on using what they have before they sometimes are ready to deploy new ones. Right.
Okay. Another very big topic within this sector is distributed energy resources, right? And what about the role that they can play in grid resilience? Can you just talk about, well, first a bit, just explain to people who perhaps don't know what they are, and also how they can help in terms of grid resilience?
Yeah, so it also really touches on what I'm working on now. So right now, my current role in Energy Insights, it's a project to bring basically data monitoring to small to medium manufacturers in the state of Indiana. But as many people know, there's also many efforts to bring solar behind the meter. So we can start measuring the loads behind the meter, and you can start measuring solar behind the meter. But these are mostly invisible to the utility right now. They don't always, they can guess, or they know when you put on solar, and they can use sort of weather models to guess when it'll be on and off. But they don't receive any data from the grid. But there is no zero carbon scenario.
Yeah.
That doesn't rely on this future of the grid where there's solar everywhere and there's load resources that can be turned on and off. Turning on and off load is so much cheaper than building a whole nother power plant, that if you can find those opportunities for flexible load where people are like, hey, July 5th on the hottest day of the year, I will turn my load off for 4 hours, that is so much less expensive than building the nth power plant out there, that there's no realistically priced grid scenario of the future where it's especially zero carbon grid scenario of the future where load is not playing a much more interactive role with the utility. And so we aren't there yet. There is not a connection of the data from the DERs, which can, as a distributed energy resources, can include true generators and load that's raising their hand and saying, I'll turn off on the hottest day of the year. Or I can just turn, or some loads are a little more flexible every day, but mostly they want to participate in something called demand response, like just turning off on the hottest day of the year or the highest load day of the year. Or in the future, it won't necessarily be the hottest day of the year. It might be the cloudiest day of the year. We'll see when that happens. If there's a lot of solar out there, or the least wind day of the year. But anyway, those are both called distributed energy resources. One is real energy. One is just raising your hand and saying, I'll turn off my load. But anyway, they're in the same category of DERs. But both of those things can are necessary if we want to get to this future. And so starting to get that data back and forth between the utilities and the DERs is kind of the ultimate connection point that needs to be made for us to really be able to deploy AI, predictive analytics, AI, all of these things about what's going to happen in the grid. And so that's kind of the linchpin of where we'll go next after all these things have been picked up, and that's where AI will play an incredibly important role in the grid. We just don't have the data connected yet.
Yeah. Okay, perfect. And that's a great segue, I think, to the next topic, which I want to speak to Ravi about. So you mentioned it a few times there, Becca, in terms of predicting what's going to happen, detecting threats to grid resilience. This obviously helps avoid a lot of disruption if we can manage to do that more effectively in the future. So Ravi, why is having scalable, reliable, and real-time data important for predictive analytics when it comes to grid resilience?
Yeah, absolutely, right. And thank you for asking me that question. And it's a very perfect segue as well into what we do, because you need the data across all of these different systems within your grid to be able to bring the data, so that when you try to do predictive maintenance, you can do it at a holistic level as opposed to individual level. Like Becca mentioned, that you cannot do like predictive maintenance on a ballpoint pen, right? So that you can do some of that, but if you really want that to be accurate, you need to be able to do it across millions of ballpoint pens. So you need to bring all the data together from all of these different systems, and that has to be scalable, that has to be reliable. I love how she explained about reliability and resilience, right? So reliability, for example, and I'll jump into MQTT and what it does, right? It's like ensuring that you have high levels of quality of service, because when you send the data, you want to make sure in some cases that the receiver receives the data versus like I just sent it, right? So ensuring that like there is high quality of service in some cases, especially in grids. And also from a resilience perspective, right? You want to build systems where for whatever reason, if your system goes down, you want to be able to have like a backup, right? I mean, obviously, I'm not talking about hardware here, like the ones that add more copper and things like that, but like in the software world, have a redundant system, if you will, that can take over. So those are the kinds of things that MQTT and HiveMQ can bring in, right? So basically, if I can just quickly introduce MQTT, it's basically like it started in oil and gas back in the late 90s. And IBM was tapped with helping Phillips 66 out with helping connect the remote oil wells, if you will, in their upstream area, where it's basically they're in the middle of nowhere. There is high bandwidth constraints, there is connectivity constraints, there is harsh environments, work environments, and but they wanted to be able to not have to send people all the time there to be able to service and support, because it's not cost effective, because it's in the middle of nowhere, and B, it is obviously also not safe, right? So that's how MQTT was born, as a publish subscribe protocol, which is basically you have clients that can publish data on particular topics in small sizes, like 200 MB sizes, if you will, to like a centralized broker, and the broker could be sitting in like an enterprise, or it could be sitting on premise, And then the broker then is responsible for sharing it with other clients that needs that information, right? So naturally, it lends to, obviously, you can have multiple clients that are publishers and multiple clients that are subscribers. So in this case, you could have all of these different grid elements being able to publish data when they have connectivity to like a broker, and then the broker can then share that information with other solutions, like maybe a digital twin solution or an analytic solution that can then take it and work on it, right? So that's kind of like where I think resilience, and then of course security is the bedrock of all of this, right? So because you're taking the data out of your system, it has to be highly secure. MQTT has security built into it because of the fact that it's publish subscribe. It's based on specific topics, and if you're not publishing or subscribing to a topic, you won't you won't get it. You won't get the data. So there is natural security built in. But obviously, there is other security that you can do, like TLS or X.509 certificates and things like that. So to make sure that there is security at rest and security in motion as well. So that.
I think the publish, subscribe, and sharing of information across systems is it's an interesting. This ties into Becca's comment about crowdsourcing data and crowdsourcing that polls are leaning. You get smarter and you get more resilient the more connections that you actually have. And I'm just thinking about the ballpoint pen example, Becca, where
I got to get one for myself too.
It would all kind of be a ridiculous endeavor for me to apply a bunch of sensors to this for the value or the cost of it. But my eyeballs can see that this is slightly open and on the desk, and without needing to actually put sensors into that ballpoint pen, driving by or walking by, I can see, oh, wait a minute, this thing is open. And I think that's the value of, as you think about all of these islands of information that are starting to get connected by tools like MQTT, that's really the power.
Yeah. And then if you have to like fly somebody like across the world just to close that ballpoint pen, right? That's where I think it becomes very cost prohibitive, right? So if you can just figure out, hey, that ballpoint pen just needs to be slapped tight or something like that using technology, that'll be fantastic. Yeah. Hamish.
Yeah, I just want. So I wanted to because you've already talked a little bit about MQTT. I wanted to, and Ryan is in a minute we're gonna start getting practical in terms of talking about some specific use cases. But before we do that, I wanted to talk to you a little bit about standardization. And what role does standardization play in achieving these IoT use cases within the energy sector? I mean, it's always a huge issue in all other technology areas as well. But perhaps you can give us an energy specific insight into the role that standardization plays.
Sorry, that's to me, right? Just to be clear.
Yes.
Okay. All right. Yeah, for sure. Yeah. So standardization obviously is absolutely important. And that's kind of like where MQTT actually got its popularity as well, because yes, it started in oil and gas way back in the 90s, but it was still for a long time not really used since then, until it became like an open standard in 2010, right? That's kind of like where I think it became more accessible to others to experiment and start using and then start seeing the value. And now if you look at MQTT, it's kind of like prevalent across so many different industries, right? It went from oil and gas to other aspects of energy grid use cases, manufacturing, connected cars, and so many others, right? And that's the power of standardization, where I think like you're exposing it to more people, right? I think like the major things with the advantage of standardization is that you have, at least in the world of software, right? I mean, you have like a reusable piece of software that you can reuse across multiple different systems. So you don't have to keep reinventing the wheel. The reality today is that companies have a very siloed organization, so which means that the left doesn't know what the right is doing. So they might be doing exactly the same thing, but they're spending like millions of dollars basically developing the same things. And if only they could work with each other and kind of like standardize on certain things, use standardized protocols like say an MQTT or a Sparkplug or something else, and then build on top of it based on what they need, that would be the right way to do it. So it is awesome. It is great from an interoperability perspective. That way, there are certain things that's already taken care of, and all you need to do is build things on top of that. So you're able to easily talk to, say, sensors, meters, controllers, software applications, because they're already conforming to the standard, right? Integration of new systems becomes easy. So you're bringing in new systems, and if they are based on open existing standards, they're much easier. Efficiency is great, because obviously, like, you want to make sure that you're highly efficient when you deploy new systems, and you try to optimize them from a transmission, from a processing, from an analysis perspective. We already talked about scalability. I mean, scalability is also great, because once you standardize, it's easy to scale. Security, and then, like, last but not least, regulatory compliance, right? I mean, if you obviously you have to comply with regulatory bodies. Standardization is of great use to you, because this way you make sure that every system that you have across your portfolio are conforming to the same standards. So that way you can be sure that you're compliant. So these are some of the things that standardization helps with.
Ryan, did you want to say something else about that, or?
No, I think all the tools are there. The foundational pieces are there. I'll talk a little bit later about, are we actually seeing it? And maybe not quite as positive as you guys seem to see a much more change happening than I'm witnessing. So.
Okay, well, in that case, let's get into it, because it's always good to have some diverse perspectives, some diverse views. And as I
there's
said,
always a good and bad and ugly to everything, right? So
exactly. So and as I said, I always like to get practical and provide examples of what's really happening out there. So let's do that. I think there's a recognition that generally speaking, sustainability, grid resilience, all these things are a good thing, right? And everybody's talking about them. But Ryan, maybe you can give us your perspective on what are you seeing in the market actually happening or not happening, and if, as you seem to be suggesting, it's not happening as fast as we might want or expect, then what are some of the reasons why these technologies are not being adopted so rapidly?
That's a loaded question. But I guess let me start. I didn't mean to be negative. It's there is a lot happening, and I think it's almost like the story of how do you eat an elephant one bite at a time. Each of these little things that are happening, that are changing within our environment, within technology, are building on themselves, and back to that point of being able to crowdsource information. The more interoperable we make systems, the more that we will experience an exponential adoption of some of these technologies. So while you may not see a lot of the change when you're out in the field, that change is happening. Every new piece of equipment that comes in, every new plant that goes up, they're better instrumented, they're better able to communicate. Whether we're actually doing it yet or not is a different question, but at least the capability is there. I would say, and we deal primarily with the mid-market and smaller. There's some large customers we deal with as well. And in that world, I would say that, and even in the big customers, actually, it seems like there's a lot of lip service to, like, everyone's got sustainability on their website. Everyone says it's important. Of course it's important, but it's definitely not driving systematic spend at the operational level that I'm seeing. If you have to buy a new piece of equipment, of course you're going to buy it sustainable, or of course you're going to buy it with instrumented to be able to be optimized and to act in a resilient manner. But most of what I'm seeing is primarily on the corporate reporting side. It's financial exercises. It's better accountability at the overall enterprise level. But in terms of driving better asset utilization, capital changes in the factory, it seems to be much more financial and strategic than practical, actual. Now let me go back and say that I have a customer, someone I consider fairly innovative, and he tells me that sustainability and resilience are a bit like safety. These are leading indicators on factory performance. Focusing on these areas drives a mindset change, drives a process change that affects not just the one metric, but every metric downstream. And so his approach is by relentlessly focusing on systematic metrics like safety, like sustainability. The efficiency and productivity tend to fix themselves.
Yeah.
And that allows him to be much more of a carrot manager versus a stick manager. So I think that while there's not enough change happening at the sustainability level, I see this as a real opportunity, not just to improve grid resilience or consumption, but to actually improve the overall performance of the system as a whole.
Just Hamish on that point, right? I mean, even a very simple thing like reducing paper, right? Because obviously paper is used a lot in the energy industry. Just reducing that, right? I mean, not only are you more efficient, right, using more digital technology, but you're also sustainable. So sustainability and the other aspects of what you want to do are actually in some cases complement, as opposed to, oh, if I want to try to focus on sustainability, I had to give up on my dreams to be more efficient, is not really the case. You can actually it can go hand in hand. So and that's a great example, Ryan.
And so presumably, though, part of what that implies is that your customer in that situation has to be the one who makes that connection clear to the board, or to whoever. So that's part of the solution, really, isn't it? Is better internal communication of the business case for actually doing this stuff and using these tools, right?
Yes, absolutely. And it's a more difficult business case to make, because you're connecting several dots. You're looking at safety, and then you have to look at, over time, there's an improvement in overall performance. Was that the cause of it, or was it related to it? I think in his case, he's looking at the data in aggregate, and he's just saying this makes sense. But from the business case itself, it's rarely specifically about sustainability. He's not going to his board and saying, if you add these sensors, if we do a better job on reporting, we're going to drop our carbon by blah. I'm going to get more efficient, and because of that, I will also make an improvement in some of these other metrics.
Okay. So what are some of the practical ways that that these tools can be used then? If people do want to start utilizing them and are making that case, then what are the practical ways that they can get started doing that?
Well, I'd argue that these aren't just around energy and grid resilience. Manufacturing is a complex system, just like any other system. It's like instrumenting the human body. When you go into a doctor, they do multiple readings all over the place in order to determine whether you're sick, or what might be causing that sickness, and help guide them towards the solution of improving your health. And just like any other system, the signals can tell you a lot about the health of your plant, especially as you look at some of the supporting assets. So electricity, gas, air, all the things that you need to produce, but aren't necessarily directly consumed or tied to the production. Often it is far less invasive to measure, to analyze, to stitch together those systems than it is to overhaul your equipment. And to me, that's the real place to start from a small and medium manufacturing standpoint, where you just don't have a massive corporate initiative driving you to do something about sustainability. And in the process, you actually learn about smart manufacturing and some of the tools that are available to advance your overall system, like the MQTT as a communication. So to me, this is, and I'm going to bring it back to Becca, this is why I'm so excited about what they're doing in Indiana. And I would love to see this spread to other states, because by instrumenting the plant in non-invasive ways, using CT sensors, vibration sensors, general purpose vision, integrating things with a wireless network technology, so you don't need to overhaul the physical network. And this part is important, done in conjunction with an integrated, open, scalable framework that includes the ability to leverage templates, that includes the ability to share information, if so desired, with other systems. The system that they put in with the Energy Insights starter package, it is telling you something about how your actual plant is performing. You can start to derive insight from the signals within that system as they relate to the broader system. And more importantly, you have an example to use in terms of a best practices architecture, modern technology, modern, everything from the sensing technology all the way to the data management side of it.
Right.
You can then replicate into other modernization efforts. So instead of energy as the focus, or energy as a nice to have, but I have to swing back and focus on whatever problem of the day that I happen to be having, energy optimization and resilience and sustainability are, to me, actually the easy, happy path to smart manufacturing.
No, absolutely. I second that, right? I think it all starts with the overall company goals, where you want to go, right? And then again, it's all about how do you make sure that your people kind of like rally around that, and then how technology can come in, right? Obviously, your brokers, your cloud solutions, your analytics, and other things, sensors, smart sensors, everything can come together to help you get there, so that you can show value, and then you can grow, and you can scale up to where you want to be, right? That's
Okay, and it's interesting you mentioned people there, because I always try to get into these sessions also the human aspect slightly, because there's a danger we dive into deep tech rabbit holes and forget about the people, which at least for now are still key to the whole thing. So Ryan, I wanted to ask you finally, what in terms of changing patterns in the workforce, how is that potentially accelerating or limiting the adoption of AI and IoT? And how could that affect the contribution that the manufacturers can make to all of this?
Well, whether we like it or not, human labor has become a scarce commodity, and it's become a bottleneck to global manufacturing output. Certainly in the U.S., as there's all sorts of reshoring and nearshoring and changing of the supply chain, I would say that this is probably the biggest single driver of AI adoption and IIoT enablement, at least on the brownfield side, over any sort of legislative change or catastrophic events or things that are driving or that might be tied to purely the sustainability or the I think that just the workforce changes in general are we have to do more with less. We have to get the value that is locked up in the workforce, the labor workforce, out, and we have to be able to share assets. And again, I think this all comes down to a bit of a network effect where you can't afford to have a specialist for every function. You have to have the ability to learn from and share the knowledge, share the expertise across an overall organization. So data-centric technologies like IoT, like AI, are a way to take older assets, including older human assets, and allow them to be optimized, allow them to share across teams, across facilities, allow them to link the supply chain at a much more granular level, not just at a macro signal, but and ultimately this continued networking of systems allows you to improve performance as a whole. And fundamentally, the biggest single thing that I witness plant after plant after plant is the labor issue is driving the adoption of new technology. Where robots used to be, that was a bad thing to be seeing in a plant, and you wanted to get it out as quickly as possible. And often they made things fail as a technology. You're finding workforces are saying, no, let's adopt this, let's use this. I want to be able to do better. It's also a way to increase your worth as an employee and increase your ability to contribute to the company, to contribute to the system that you're part of. So I'm quite positive on this aspect as necessity drives innovation, and that's what we're seeing.
Yeah. Just the last point that Ryan raised, right? I completely agree with that as well, because what I see is that automation is here to stay. And I think automation is looked at now as a way to just automate the mundane jobs that people do that potentially they can keep repeating and make mistakes, as opposed to that, if you can automate that, you can then focus on the more highly skilled jobs that need to be done, right? That really takes the company to the next level, if you will, right? So that's kind of where, and then generative AI is a big aspect of that these days. You keep hearing that's coming into play to automate a lot of these things as well. So
yeah, absolutely, and I'm seeing it in my own world as well. And I think that the exciting thing about generative AI is that it's not just about freeing up time; it's actually enabling you to be better at what you're doing. Right? It's a tool that can actually make you better. And I think that's the answer to all the people who are running around like headless chickens saying, oh, there's going to be no jobs and all the rest of it. Well, actually, at least for the now, if you have the opportunity then to get your head around this stuff and start using it, then it can actually enhance your performance and make you more valuable to whatever organization you're working for.
Yep.
This is just such a neat time to be in the industry. We were at a customer last week doing a training workshop across many different plants, several different divisions. They had chosen to move forward with a technology platform that's enabling this systematic thinking, enabling standardization. But the coolest thing about that exercise was seeing the people in the room. And you had factory planners, you had frontline workers, you had technicians, you had engineers, and they were all able to exercise the same tool sets and learn in the things that would traditionally have been either a very specialist requirement or would have simply been out of reach, were the tools that they were now able to use and think about and add value within their own job, but within their system, and consider workforce development. So that was just one example of many. But I think that we live in in a pretty interesting time. And it's a time that is going to continue to get, tying it back to resilience and sustainability, it simply has to get more resilient and more sustainable, the more connections we have.
Yeah.
Absolutely.
Learn to adapt or be left behind.
All right. So thank you everyone for your insights. I think that's a great point at which we can move over into some questions and put you guys on the spot. And I think to start off with, we'll stay on the human theme for a minute because Brianna Sandquist, fantastic name by the way, has asked, do the companies actually have the people at the moment? And if not, is it a question of training the people you have? Is it a question of, students, better university specializations coming out? Is it about getting maybe people who've already retired back into the workforce and training them? How do you see filling that talent gap?
I'd say all of the above.
Okay.
And I would start with the workforce you already have. There's so much untapped capability in many environments, not all, but many, and then move to think non-traditionally. There's so many people that are willing to contribute that have moved into retirement or who have chosen to step away so they can raise children or whatever.
Mm-hmm.
But today, in a much more connected, much more data-centric universe, they are able to continue to contribute. And I would think non-traditionally and really put pressure on your HR teams and your legal teams to allow thinking non-traditionally, because there's so much more value that's out there. So
yeah. And this is where I think like AI also comes in, right? I mean, if you feel that you don't have the right skills, maybe the people with skill are retiring and new people are coming in, you have to complement their work with some automation tools, with AI, so that they can do a better job, right? It's not that they're like not good enough for it. It's just that they're new. So the more you can handhold them and help them out, the more they'll become motivated and do a great job and build the skill set over time.
Yeah, absolutely. All right. Another question now from Alpa Demir. What are the KPIs for grid resilience?
Open-ended, huh?
that's probably the best here.
A lot.
Yeah. So, what's really well defined are the KPIs for grid reliability, and your friendly local neighborhood public utility commission can tell you those, because you have targets for each state. And they're very specific. SAIDI, SAIFI, that's SAIDI, SAIFI, and it's very specific about how many minutes was each customer out on average, how often did each customer go out on average, and how, and KD, I guess, is how long did it on average take them to get back online. So those are very specific and well known, and you can measure those KPIs for any distribution grid, and it's easy. What's less clear is what is the resilience, those once in a lifetime events, those crazy, outages that nobody expected. How do you create KPIs around that? And resilience isn't about predicting and knowing things are going to happen always. I know that this is predictive analytics for grid resilience is the title. So, but really, usually it's about getting back up after an outage. So there may be more specific KPIs that I don't know, but I think they're mostly around how quickly can you recover from this asset going out or this asset going out? How many assets can go out before you can recover? And so those would measure your resilience. It's about bringing stuff back alive after a major outage is one part of it. And then, and also the cascading effect, like making sure one outage doesn't affect another, would be a measurement of your grid resilience. I have less of a quantitative background in that, so maybe others know, but I don't know the specific KPIs around resilience, or if they're nationally defined in a clear way.
Okay, fair enough. A question from Lothar, staying on grid resilience, from Lothar Breuss. Maybe he's German, not sure. What is your prediction about when grid resilience will be improved by AI-based real-time decisions?
Great. I would also say there will be a human in a loop as long as I'm alive. When it comes to making real-time decisions about the grid, I hope, actually. I do think that things will be getting, the ways I've seen AI pitched to the utility have all been around reliability for the most part. Like I said, very few have been around resilience yet. They've been like, how do we predict the outages that are coming next? And they're very far from real time. They're like, yeah, drive around with a truck, and then the truck is constantly taking pictures. We're using AI to turn those pictures into data. They tell you the pole is leaning or the transformer is hot or whatever. And then you send that back, and it's very far from real time. And those are, honestly, they're just being pitched to utilities at this phase. I think that, again, the AMI meter data is this like elephant in the room, and AI is going to start looking at that data, and probably already is in many cases looking at that data and making making decisions. But I still think it's pretty far from the real time. So when will it start being a real time decision? Well, I hope there's always a human in the loop, and I think it'll be like within 2 to 5 years, it'll be closer to real time. Like AI will make a recommendation to the human in the loop, and then the human will make a decision. I don't know. Maybe I'm an old person. I'm a Luddite. I'm not getting a human out of that grid resilience loop. That's like our, that's how we get taken over by the robot.
I think that's what we've been talking about as well.
If you lose your electric grid, we don't want that. Yeah.
We don't want complete automation, but you want to automate whatever it is that is automatable, but you still want to have a human there to be able to.
And there's already, if there's people who stare at dashboards all day, staring at dashboards can be done by a machine today, like looking for trends, looking for things, and learning what the operators know and do. They can do that. And that's what I will say will start happening in 2 to 5 years. Those lookers at dashboards can be replaced by AI. But not totally replaced. Not gone, just not constantly having to stare at so many data points at the same time.
I would add, though, that I wouldn't wait. This isn't, I think this is something that's incremental, and it's small bites over and over and over again. And it comes back to like Becca's program in Indiana. Every little step forward helps the overall system. And there's so many things that manufacturers can do, at least on the demand side of the meter, to improve their performance in general by focusing on sustainability, resilience, and just trying to drive some of these improvements so that they actually result in business benefit, and that will hasten in that world that Becca is describing, where the system functions as a uniform whole.
And I was just going to, I think we have time for one more. I can see the best Becca is maybe replying to this in the chat, but Salima has asked, is DLR and AI the best combination to make the grid more reliable?
Great.
All right.
DLR is a great way to squeeze more out of copper. Like we have hard assets, and DLR is just a way to squeeze more out of. Sorry, up there. Just squeeze more out of what we already have paid for. So I don't know. The best way to make a grid more reliable, right, would just be add more copper everywhere and pay $1 bajillion. But in the world that we live in, we're trying to transition to a totally new grid and not pay $1 bajillion for copper everywhere. DLR is one way to enable that, to squeeze more out of what we have. So with demand size resources, what I mentioned, load control, all of these things are a way to squeeze more out of it. And AI is just kind of the enabler that lets us, now we have all this data. We got too much data. We can't look at it all. And we're trying to run this squeeze grid in a better way. And I think AI would be the enabler for that. But yeah, I guess, what is best in this world? If best is just the most reliable, like our whole country should be a copper plate. And we're just paid $1 bajillion and everything transmits exactly as we would like. But I think if we're squeezing, we got an AI to use all the data to make sure it doesn't break.
All right, perfect. Perfect. Thank you very much for that, Becca. I'm afraid we're out of time, so it just remains for me to say thank you to all our panelists for your great insights. Thank you again to the sponsor, IoT World today, and thanks to all the people who have attended and listened in. I hope you enjoyed it. I hope you found it useful, had some great questions. The questions we didn't get to will get answered afterwards. We'll organize that for you. I'll see you later for sessions on data historians and cybersecurity. And in the meantime, enjoy the next session, which is Mirroring Success, Digital Twins and their Strategic Role in Business Resilience. Have a great day.
Thank you.